Hey everybody, it's Mr. Oaks. So we're talking about transformations, and if we remember, transformation is something that we do to a shape or a point or a line that is going to change it in some way, usually the size or the location or the orientation, and sometimes it's the shape as well. But what we're going to talk about today is reflections. So if you think of a reflection, usually you think of a mirror. And if you think of a mirror, what happens is when you look in a mirror, your right side on your person is the left side of the image of you in the mirror. And that's what we're going to do kind of in this video. But one of the things we also kind of look at is that when I'm looking in the mirror, I'm the same distance from the mirror that my image on the other side of the mirror is from the mirror. It's a little weird to think about, but next time if you're looking at a mirror, take your hand, go towards the mirror, and when you touch the mirror, you'll notice you're touching your image's finger. So if you stop and think about it, your image is the same distance inside the mirror that you are outside of the mirror. It's weird, I know. But one of the things with reflections when we talk about geometric transformation, so a geometric reflection, is that what's going to happen is the image is going to flip. And it's going to flip based off of the line of reflection. So again, when I think of a reflection, if I think of the word reflection, we got that FL there. So what you want to do is you want to think of it as a flip. Okay? I'm going to flip the image. I'm going to flip it left, right. I'm going to flip it up, down. Okay? Or up, down. And that's what we're going to do here. And it all depends on what they're telling us we need to do. So the ones that we're mostly going to see in 8th grade math are reflections across the x-axis and the y-axis. Those are usually the most simple ones. But really, any reflection across any vertical or horizontal line is really not that difficult, because all we're really doing is we're seeing how far from our line of reflection is the point that we're reflecting. So, for example, we have here triangle ABC with points A 2, 4, B 6, 5, and C 4, 2. When we reflect it across the y-axis, that's going to be a left-right flip. So first off, our line of reflection is the y-axis. So what I can do is I can kind of draw a little dotted line, kind of highlight the y-axis a little bit. And what I'm going to do is for each of the points in the triangle, I'm going to count how far away from the line of reflection it is. So when I look at A, it's 2 points away, 2 units away from the y-axis. So its reflection is going to be 2 units in the opposite direction. So this is 2 units to the right of the y-axis. Our reflection is going to be 2 units to the left. So 1, 2. And we're going to call it A prime. One of the things you want to remember is our original shape, our original figure is known as the pre-image, the before image, and our shape that comes after is just the image. And we represent each of its vertices, each of its corners, with the same letter as our pre-image letter, in this case A, but we add this little apostrophe, which we say as prime. So this is A prime. B, we look, B is 1, 2, 3, 4, 5, 6 to the right, so 1, 2, 3, 4, 5, 6 to the right of the y-axis. So B prime is going to be 1, 2, 3, 4, 5, 6 to the left of the y-axis. C is 4 to the right of the y-axis, so C prime is going to be 1, 2, 3, 4 to the left of the y-axis. And when we connect our points, we see that now not only is this in a different position, basically in a different spot on the graph, the orientation, the way the points are situated within the shape is now different. So instead of here going clockwise, we have A, B, C. In the image, they're counterclockwise. A prime, B prime, C prime. Now, there's a couple other things with this. When I look at the coordinate for A, that's 2, 4. The coordinate for A prime changes our x value. We now have a negative 2, but we're still 2, 4. B prime, same thing. We're now a negative 6, 5. And C prime, we are now a negative 4, 2. So because we went across the y-axis, our x changed its sign. So we can show a general rule of when we have the point xy and we reflect it across the y-axis, we're going to wind up with negative x, comma, y. So the y is going to stay the same, but the x is going to change its sign. Okay? And when we look at this, again, the lengths of each of these sides is still the same. Okay? They're all an angle, so it's a little tough to tell how long they are. This is 2 square root 2. All right? This is 2 square root of 2. The angles are going to be the same. So if you measure the angles here for A and for A prime, that's going to be the same angle. Okay? So not too bad. We're just flipping it. You notice, flipped. So now we have here, we're going to reflect across the x-axis. We're going to reflect across the x-axis. So notice I have quadrilateral A, B, C, D. I didn't write down the points. Okay? But A, I'll just use A as an example. Point A is at 1, 2, 3, 4, negative 5, 4. We're going to use that as our point that's going to show the rule for when we reflect across the x-axis. Now again, our x-axis is our line of reflection. So that's this right here. Okay? So we want to count how far each point is from the x-axis and then go in the opposite direction to get its reflection. Okay? So here I have 1, 2, 3. A is 4 above the x-axis. So A prime is going to be 1, 2, 3, 4 below. There's A prime. B, well, B is right on the x-axis. It's not above, it's not below. So B prime is actually going to be in the same spot. B prime. C, well, the C is 1 below the x-axis, I should say. So we're going to go 1 above for C prime. And D is 1 above, so D prime is going to be 1 below. That's awful. But, oh. So you see, these two shapes actually overlap. Now we had A was negative 5, 4. A prime is still a negative 5, but now its y value is negative 4. So in this case, even though we were going over the x-axis, it's the y that changes its sign. So we can write that rule as x comma y, when reflected over the x-axis, is going to give us, our x is going to stay the same, but the y is going to change its sign. So if it's positive, it becomes negative. If it's negative, it becomes positive. Then I got this one down here. This one's a little different. It says reflect across x equals 1. So we have our triangle here. I don't see that line there. So I'm going to draw my line of reflection. Let me come on the other side here. So it says x equals 1. So I'm going to make a little dotted line at x equals 1. And just like I was doing before, I'm going to go and I'm going to count how far my point is from the line of reflection. So we have here, this is 1, 2, 3, 4, 5, 6 from our line of reflection. So I'm going to count, hope I did enough. 1, 2, 3, 4, 5, 6 to the right. So there's A prime. B prime, well, B prime is 1, 2, 3 to the left of x equals 1. So we'll go 1, 2, 3 to the right of x equals 1. Lastly, we got C down here. C is 1, 2, 3, 4 to the left. So we'll go 1, 2, 3, 4 to the right. C prime. Now again, we look, we have the same length. So if we look at AB, AB is 3 units wide over here. A prime, B prime, A prime, B prime. 1, 2, 3 units long. So the length doesn't change. And if I had a protractor and measured the angles, those would also stay the same. So when we go and we do a reflection, we preserve length of the sides and we preserve the angle measures. Now I'm not going to write a little rule for this because usually we're not going to have that, and really what we would say is x, y, the reflection, there's going to be addition and a negative in there. Okay? And the last thing we're going to do is, this was, okay, they're giving us a rule and we're going to draw the image, we're going to draw the reflection, but sometimes we're going to be given the reflection and we're going to be asked to find the rule. So the thing that we have to do is figure out, where is our line of reflection? So what I'm going to do is, I'm going to look at my pre-image and my image, and I want to find the halfway point. So I'm going to go and I'm going to look and I'm going to say, well, okay, how far apart are these 2 points? Okay, they're 1, 2 apart. So half of 2 is 1. So I'm going to put there. I can also do here. I got 1, 2, 3, 4, 5, 6 apart. So halfway is 3. So 1, 2, 3. I'm already kind of seeing that it's looking like the y-axis is our line of reflection. I've checked with the last point. 1, 2, 3, 4, 5, 6, 7, 8. To get from x to x prime, there's 8 spots. Well, half of x, a half of 8 is 1, 2, 3, 4. Yep. The y-axis is our reflection line of reflection. So we can write, what's the rule? Reflect across y-axis. Nice and simple. Okay. We'll do the same down here. Okay. So my pre-image is up here in blue. It's polygon RSTUV, and we have our image down here, R prime, S prime, T prime, U prime, V prime. And we're going to do the same thing. We're going to count. So I'll start with R. R is 1, 2, 3, 4, 5, 6 from R prime. So 1, 2, 3. Here's our halfway point. S is 1, 2, 3, 4 away from S prime. So we'll do 1, 2. It's looking like I'm going to have a straight line across here. T is 1, 2. So again, U, 1, 2, 3, 4, 5, 6. So 1, 2, 3. V is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 away. So we need 5. 1, 2, 3, 4. What do you know? So here is my line of reflection at y, I'm going to say x, y equals negative 11. So this is reflect across y equals negative 1. And that's how we find out what is the rule. What is our instructions on how we made this reflection. I hope this video was helpful in figuring out reflections. If you did find it helpful, please like and subscribe. Feel free to comment about what you feel worked and what you feel didn't, and also to give suggestions about future videos. I'm Mr. Oaks. Have a good time.